In this next section, we'll be looking at the quotient rule. The quotient rule tells us what to do when we have two functions that appear as a quotient, where we could take the derivative of the top and we could take the derivative of the bottom. This helps us know how to put that together. So here's the way that the book gives it. Here's the way that I give it. Let me look at this verbally, what we're going to do. Basically, if we're given a function where we have the numerator over the denominator, think about this top over bottom, we always have to start with the derivative of the top. This is important because we have subtraction. Product rule, we could do it either way, but quotient rule, we need to start with the derivative of the top, and then we multiply it by the bottom. We subtract, and then we keep the top, multiply it by the derivative of the bottom, and then we divide it by the bottom squared. So the bottom's going to stay on the bottom, but we're going to square it. So if we think about this as a function over a function, h of x over g of x, we'll write it as h prime g, so derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So here's an example of doing it. So we have the top up here, x to the third minus 4, bottom down here, x squared minus 3. Let's color code these. Okay, so red on the bottom, blue on the top. So if we're taking our derivative, f prime of x will be equal to, first of all, we're going to make this a quotient, and the derivative of the top is 3x squared. We'll then multiply that by the bottom, which we're going to leave the same. We then use subtraction, and we keep the top the same. And then we multiply by the derivative of the denominator. We then rewrite the denominator, but we're going to square it. Now we can simplify this a little bit with the 3x to the fourth plus 9x squared minus, and make sure you're careful with the distribution here, 2x to the fourth minus 8x. Keep the bottom the same. Now usually it's not worth multiplying the denominator out, so we're just going to keep this as x squared plus 3. We'll continue to simplify the top though, x to the fourth plus 9x squared plus 8x all over x squared plus 3 squared. Sometimes the book will ask us to do this with numerical values. Now this first example, we'll use one that is a product, which will be using our product rule. We should remember our product rule will be the derivative of the first times the second plus the first times the derivative of the second. The difference though is now they're giving us numerical values rather than an actual equation. So they're saying find y prime of 2. So we're going to start by thinking, okay, I need the derivative of my first part, the u. So the derivative of the first part, u, would be negative 4, and I multiply that times v. So we find v of 2, here we are, and it's a 1. Plus, the next part then we're looking at u, and so u of 2 would be 3 times the derivative of v at 2 would be 2. So even without knowing our function, if we know values at those different parts, we can still find the value of that function, or the value of the derivative at that point. We can do the same thing with the quotient rule, only this time we're going to rewrite our rule. Think about this as the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So if we're thinking about this, if we're looking for f prime at 2, we need to plug those values in. So I left these 2's off of here, but we know that they belong there. So starting with u prime, we are negative 4. Our v would be 1. Our u then, u of 2 is 3, and v prime at 2 is 2. And this will be divided by v at 2, which would be 1 squared. And so this one will simplify to negative 4 minus 6, or negative 10.